Okay, Common Core Algebra 2, Lesson 2, the division of polynomials. And we're going to solve these division problems by using the reverse tabular method. So I know I'm dividing by 2x minus 3. That's my divisor. So 2x minus 3 goes over here on the side. And I need to figure out how long the top of my table is. And I know I have an x cubed divided by an x. Well, x cubed divided by x is x squared. So I'm going to end up with a quadratic polynomial up top here. And quadratic polynomials have an x squared term, an x term, and then a plain old number. So I need 3 columns. From that diagonal, I need to get out a 2x cubed. From this diagonal, I need an x squared. That diagonal, I need a negative 16x, and then I need out a 15. Remember that we take our dividend, the numerator, and that's our result that we get from the multiplication question. So I know a 2x cubed goes here, and we need to say, what times 2x gives me 2x cubed? Well, that's x squared. X squared times negative 3 is negative 3x squared. So now we move over and say, what plus negative 3x squared gives me x squared? 4x squared does. 4x squared minus 3x squared gives me x squared. What times 2x gives me 4x squared? 2x does. 2x times negative 3 is negative 6x. What plus negative 6x gives me negative 16? Well, negative 10x does. Now we say, what times 2x gives me negative 10x? Positive 5. Positive 5 times, not positive 5, negative 5. Negative 5 times negative 3 is 15, as we desired. So that quotient is equal to x squared plus 2x minus 5. That's our final answer. Number 2, x cubed minus 8 divided by x minus 2. So I know I'm dividing by x minus 2. And I need to figure out how long it is across the top, how many columns I need. Well, again, x cubed divided by x is x squared. X squared quadratic polynomials have an x squared term, an x term, and then the number. So I need 3 columns. I know I get out an x cubed from here, but I don't just put in minus 8 there. Remember, x cubed polynomials have a x squared term, so plus 0x squared, plus 0x minus 8. These x cubed minus 8 is equivalent to that polynomial there. So I want a 0x squared, a 0x, and a minus 8. Don't forget to ask yourself what's missing in case we have x cubed minus 8. We're missing those x squared terms in that x term. X cubed goes in that box. What times x gives me x cubed? X squared does. X squared times negative 2 is minus 2x squared. Now we say self, what plus negative 2x squared gives me 0x squared? Well, the additive inverse is 2x squared. If I add those together, I get 0x squared. What times x gives me 2x squared? 2x plus 2x. 2x times negative 2 is negative 4x. What plus negative 4x gives me 0x? The opposite of that does. So there's a 4x there. What times x gives me 4x? Plus 4. 4 times negative 2 is negative 8 as we want. So the quotient is x squared plus 2x plus 4. Number 3. We have this 5th degree polynomial divided by 3x squared minus 1. A little warning light needs to be going off because of what's missing here. 3x squared plus 0x minus 1. We need to fill in that missing term, otherwise our table won't line up and the diagonals won't line up, and reverse tabular method will just fall apart. How many columns do I need? X to the 5th divided by x squared. X to the 5th divided by x squared is x cubed. So I need an x cubed column, an x squared column, an x column, and a number. So x cubed, x squared, x number. And from that diagonal, I get 3x to the 5th. From that diagonal, I get 12x to the 4th. From that diagonal, I get 11x cubed. From this diagonal, I get 2x squared. That diagonal, I need to get out minus 4x. And from this diagonal, I need a negative 2. So I know this entire row is going to be 0 regardless of what I add in. That's just a placeholder row. 3x to the 5th had to be in that box. So what times 3x squared gives me 3x to the 5th? X cubed. Multiply through now, and I know I get a negative x cubed down here. I move over to the next open box in the top row. What plus 0 had to give me 12x to the 4th? Well, that had to be 12x to the 4th. Now we say self. What times 3x squared gives me 12x to the 4th? Well, that's going to be plus 4x squared. Because x squared times x squared is x to the 4th. Multiply through. 4x squared times negative 1. It's negative 4x squared. Move over to the top, the next open box. What plus negative x cubed gives me 11x cubed? I need 11x cubed, and I have a negative 1x cubed. So that needs to be 12x cubed, because when I add those together, I get 11x cubed. What times 3x squared gives me 12x cubed plus 4x? Multiply through. Move over to the next top open box in the top row. From this diagonal here, from this diagonal, I need to get a 2x squared out. I need to get a 2x squared, but I have a minus 4x squared. So what plus negative 4x squared gives me 2x squared? I'm going to need a 6x squared up there. What times 3x squared gives me 6x squared? Plus 2. Multiply through. I got negative 2 as I wanted. So the quotient is x cubed plus 4x squared plus 4x plus 2. Alrighty, so we're dividing by x plus 1. And I'm just going to look at the numerator quickly. I have x to the 4th, x cubed, x squared, x. I'm not missing anybody. So x to the 4th divided by x gives me x cubed. So I need a column for x squared, because x cubed, x squared, x, and then a number, because x to the 4th divided by x is x cubed, x squared, x number. From this diagonal, I get x to the 4th, and that diagonal 2x cubed, 2x squared, 2x, and a 1. So x to the 4th had to come from that box. What times x gives me x to the 4th? X cubed does. Multiply through. X cubed times 1 is x cubed. I need 2x cubed, so there had to be another x cubed there. What times x gives me x cubed plus x squared? Multiply through. I want 2x squared from this diagonal, so that had to have been an x squared. What times x gives me x squared? Plus x. Multiply through. I want 2x from that diagonal, but I don't have that. So I need to put another 1x there. What times x gives me x? Plus 1. 1 times 1 is 1. So the quotient is x cubed plus x squared plus x plus 1. Number 5, first compute that quotient, then express 3x cubed, that's a typo there, 3x cubed plus 10x squared minus 14x plus 4 is the product of two polynomials. Explain your reasoning. So first let's find the quotient. I'm dividing by 3x minus 2. X cubed divided by x is x squared. Quadratic polynomials have 3 terms, x squared, x, and the number, so I need 3 columns. I get a 3x cubed from there. I need a 10x squared, a minus 14x, and a 4. So what times 3x gives me 3x cubed? X squared does. Multiply through. X squared times minus 2 is minus 2x squared. What plus minus 2x squared gives me 10x squared? 12x squared. What times 3x gives me 12x squared? Plus 4x. Multiply through. I need a negative 6x to get a minus 14x. Negative 2 times 3x gives me negative 6x, and we get 4. So the quotient is x squared plus 4x minus 2. But how can I rewrite that numerator as the product of two polynomials? Well, we can rewrite this division question as a multiplication question and say that our numerator is equal to, well, if I multiply these two polynomials together, I will get out that polynomial. So 3x minus 2 times x squared plus 4x minus 2. These two polynomials are factors of this cubic polynomial. And that's a key concept. And explain our reasoning? Well, I rewrote the division problem as a multiplication problem. Compute that quotient and then compute 483 divided by 21. How are these two expressions related? So first let's compute this quotient. 2x plus 1. X squared divided by x is plain old x. So I need a column for x and a number. There's only a 2 by 2 here. So I get out 4x squared. I get out 8x. And then I get out a 3. So what times 2x gives me 4x squared? 2x. Multiply through. I want 8x. I only have 2, so that needs to be 6x plus 3. I get 3. So the quotient is 2x plus 3. Now to do 483 divided by 21. How are these two related? Well, I'm going to answer that question to answer 483 divided by 21. If I plug in an x equals 10, I get 400 plus 80 plus 3. That's the numerator divided by 20 plus 1, 21. So these expressions are related if we let x equals 10. So if I know that quotient is 2x plus 3, 483 divided by 21 is going to be, let me plug in a 10, I get 23. So remember, polynomials behave a lot like the integers do. 7, review question time. Find this product. So I'm going to use the tabular method. M cubed. I'm going to put a 0m squared there so things line up. Minus 2m plus 1. M squared minus m plus 2. You could get away with multiplication without that placeholder, but it makes your table a lot nicer. And now we multiply through. M cubed times m squared is m to the 5th. I know this is going to be all zeros, so I'll do that now. Minus 2m times m squared is minus 2m cubed. Times 1 is m squared. Next row, m cubed times negative m to the 4th. Minus 2m times negative m, 2m squared. 1 times negative m, negative m. M cubed times 2, 2m cubed. Minus 2m times 2 is minus 4m. 1 times 2 is 2. So now we add along the diagonals. We get m to the 5th minus m to the 4th. Combine my like terms here. Minus 2m cubed plus 0 plus 2m is 0. So I don't have an m cubed term in my answer. Plus 3m squared minus 5m plus 2. So that is the product of those two polynomials. All right, this is an Algebra 1 review question. 3 times x minus 2 squared minus 2 times x minus 1 as a trinomial. Trinomial, 3 terms. So the key thing is not to make the mistake that you made in 9th grade all the time. And when I square a binomial, I have to write it out twice. What does something squared means? It means it's times itself. So first let me find this product, and then I'll multiply it by 3. So x minus 2 times x minus 2. I get x squared minus 2x minus 2x plus 4. So it's 3 times x squared minus 4x plus 4. And then I'm not distributing a 2, I'm going to distribute in a negative 2. Minus 2x plus 2. Just don't distribute the 2, distribute the negative 2. Multiply the 3 in, 3x squared minus 12x plus 12 minus 2x plus 2. And then finally combine like terms because I want to write it as a trinomial. 3x squared minus 14x plus 14. Solve this equation by factoring. So when we solve quadratic equations, we need to set them equal to 0. So I'm going to have to subtract over that 6, set it equal to 0. Factoring, I need to find what multiplies to negative 6 that adds to negative 5. Well, what multiplies to negative 6 that adds to negative 5? That's going to be negative 6 and positive 1. If I multiply two things together and get 0, that term is 0, or that thing is 0. So we get m equals 6, m equals negative 1. So those are the two solutions to that equation. And finally, determine the domain and range of the following function. The domain of a function is your inputs. It's your inputs or your x values. So what are the possible x values I can plug in? Well, here's the lowest x value I can plug in. I can plug in a negative 1. I can keep plugging in all of these x values because if I plug in any x value, there'll be a y value. And then I stop there. So my domain, my x values are trapped between negative 1 and 1, 2, 3, 4, 5, 6, negative 1 and 6. And I include the equal to because those are closed circles there, which makes the range our outputs of the function, or the y values. So what's the lowest y value that I get? Well, that happens right here at negative 2. Do I get every y value in between? Yes, I keep getting all those y values. That's the highest y value. So I get every y value from negative 2 up until 1, 2, 3, 4, 5, up until 5. So my range, my y values are trapped between negative 2 and 5, and I include the equal to sign because I can get a negative 2 and I can get a 5. Alrighty. That was lesson 2.